We built a small block Chevy called Re-Rev. It made 484 horsepower on the dyno, but we want more. Today on Engine Power, Re-Rev 2.0 comes alive. We're giving it a budget-friendly rebuild and a thorough interrogation in the cell block. Plus, to keep your engine cool, sometimes it's best to hold the H2O.
Welcome to Engine Power. Today's show is going to be a little bit of a 50-50 mix. The first half is going to be a super budget-friendly refresh on this small block Chevy block. The other half is going to be a stout top-end that's going to make big power back on our Superflow dyno. Now this engine was the original bullet in our 62 Nova a few seasons ago we called Project Pro Street or No Street. We're going to redub it this time, Re-Rev 2.0.
And we're not following many rules on this build. We're going to do it our way, from the crazy color that we're going to paint the block to all the parts involved, even a power adder. And we are going to push this stock block to its limits to see what it'll do. Now sit back and follow along, take some notes if you want, but definitely have some fun with us.
After determining our cylinders are straight and round, we're diving right into the budget refresh. A drill, can of WD-40, and a ball hone you can get at any auto parts store will allow us to refresh the hone job on the cylinder for the fresh ring pack to achieve a good break-in.
The first thing to do is spray the cylinder and the hone. You have to use a lubricant when performing this job. And the speed of the ball hone is also important. Don't go above 800 RPM. The ideal speed is between 6 and 800. Insert the ball hone into the lubricated cylinder with it rotating. Now increase the speed while vigorously moving it up and down in the bore for approximately 20 to 60 strokes, depending on the bore's condition, and never allow the hone to stop spinning in the bore.
Using a piece of rectangular tube and 220 grit sandpaper, we're going to address the decks. This is to make sure the head gasket has an adequate sealing surface. Full sweeps along the deck in a diagonal pattern will create a clean surface and give the gasket a nice finish to bite into.
After that process, a wash is necessary.
Now it's time to paint the block. Common colors like black and orange just aren't going to cut it for this build. So we chose a color that will get some laughs, some people may like it, and aliens are going to fall head over heels for it. Grabber Green is the color, and it's available in Dupli-Color's Engine Enamel with Ceramic line of paints.
First, we will prime the block to give it a good base for the Grabber Green to show its vibrance. Using tape and an old timing cover on the areas we don't want primer or paint on, it makes it easy to get a block paint prepped for assembly. When applying the paint, use a light first coat. This will help prevent any runs from forming on the block surface. Following up, 2 more coats are added to give the block a full coverage of paint.
We tap the oil galleries to install pipe plugs instead of the press-in. The threaded ones give a little extra insurance. Every engine assembly must have the bearing clearances checked. We record every journal on the rods and mains. Our range for the mains is between 25 and 28 10,000ths. For the rods, it's between 23 and 25 10,000ths. Now the upper half of the rear main seal is installed. With the bearings lubed, the Eagle crankshaft can gently be laid into place. The caps go on and the ARP main bolts are torqued to 70 pound-feet with ARP's Ultra Torque lube. The crankshaft's end play is at 4 thousandths. The same cam went back in and it's installed at 107.5 degrees. A new Comp Cam's billet double roller was also installed. Here are the specs from the first go-around. The rings were file fit and the top ring gap is set at 24 thousandths. The second ring gap is also at 24. Now this larger gap is because we will be running nitrous. The calculated compression ratio with these pistons and the smaller chamber in the cylinder head is 10.92 to 1.
The bottom end will be finished out with a fully blueprinted oil pump that we did in-house. It does have a new pickup TIG welded on due to a change with the oil pan. It's a Canton pan with 6 trapdoor baffles and a crank scraper. It also has a bolt-in slosh baffle and built-in windage tray. A 7-inch deep, 15-inch wide sump gives it an 8-quart oil capacity. The half-inch NPT will allow us to monitor oil temperature on the dyno. The zinc finish resists corrosion, and it will clear a 3,750 stroke crankshaft.
Up next, the Re-Rev rebirth continues with new cylinder heads, a free-flowing intake manifold, and even a shot of nitrous.
We're back, and so is our 383 Re-Rev 2.0 build. Now it's time for the top end, starting with the gaskets and cylinder heads. These gaskets are Cometic multi-layer steel with a 27 thousandths compressed thickness. They have a 4/100 bore size as well.
For this version of Re-Rev 2.0, we are going to be switching out the cylinder heads. We'll be bolting on a set of Brodix Dragon Slayer Series 23 degrees. Now, these feature a 225cc intake port, and their valves measure 2,080 on the intake and 1,600 on the exhaust, and they're housed in a fully CNC'd 64cc combustion chamber. We ordered them set up for a solid roller camshaft, so we have the proper spring pressure. And the nice part about these is they are compatible with all stock small block Chevy style valve train.
We reused our solid roller lifters that are a tie bar design and the factory diameter of 842 thousandths. The head bolt holes in this block go directly into the water jackets, so thread sealant must be used to prevent water seepage. ARP lube is still used between the washer and the bolt head. The push rods can also be reused because of the existing cam and rocker setup. One more item that saves us money. We increased the rocker ratio from 1.5 to 1.6, but used the same type of Summit Racing's Gold Series rocker arms. They have needle-bearing roller trunnions and tips and are made from extruded aluminum. Then the rocker girdle is dropped on. The cold lash is set at 10 thousandths on the intake and 12 thousandths on the exhaust with the girdle in place. If it goes on afterwards, it will affect the lash settings.
Since we upgraded the cylinder head, we went ahead and upgraded the intake manifold as well. This is an Edelbrock Super Victor 2, and it's one of the best manifolds you can get for a 23-degree small block Chevy. With its large cross-sectional area and raised pad height, this will make power between 4,000 and 8,000 RPM, and its sheer plenum volume will reduce intake manifold vacuum at wide open throttle, which means more airflow, and in our case means more power. And just for fun, we went ahead and gave it a slick paint job and added some Earls, hoses, and fittings on the crossover to aid in cooling.
It will seal to the heads by a set of Cometic intake gaskets and Permatex Right Stuff silicone. ARP fasteners will secure it to the heads. The manifold is being crowned with a big stack, a NOS nitrous plate, a 2-inch aluminum spacer, and our 950 CFM quick fuel dyno-proven carburetor. And that thing looks awesome.
I like doing this old school stuff.
All right, now here's the question. Did you order the most important thing?
What's that?
8-inch cowl hood.
It's gonna need it for sure.
Absolutely. Cast aluminum valve covers from a previous project are being used. Aside from a couple coats of Dupli-Color paint for a new look, there was no other cost involved.
Coming up, low pressure plus high boiling point equals one great engine coolant. And our little green gremlin gets down to business.
We have a guest in the shop today. It's Mike Torval, who is the marketing director at Evans Waterless Coolant. Now today, he's going to tell us a little bit about the science behind it. A lot of people think because it's waterless, it's not a liquid. Mike, fill us in.
Yeah, you're right. Waterless does not mean liquidless. As you can see, it is a liquid, okay? But it does have different characteristics than water or water-based coolant. First of all, it stops a lot of water-caused problems like corrosion and electrolysis. And that's really important, especially for collectors and museums where cars sit for long periods of time.
Now, people associate pressure with temperature all the time. That's not the case with Evans.
You're right, it's very different. And the reason is its high boiling point of 375 degrees means that Evans is not going to form vapor, it's not going to build pressure, and it's certainly not going to boil over. And think about the lower pressure. Evans will operate at about 2 to 3 psi versus 15 in a normal operating car, or 30 in racing applications, even sometimes up to 100 psi. It's a lot safer to run at 3 psi than at those high dangerous levels that could certainly cause your coolant to blow out.
Now, one thing we really like is it's made right here in the USA.
You're right, it's blended right here in Pennsylvania.
Now, Mike, cost. Let's talk
Okay.
about that.
Sure. This is certainly more expensive than normal water-based coolant. Now remember, that contains half water, so certainly the cost is less to produce. But this is just under $50 a gallon. What we think about this is sometimes the inexpensive insurance. Insurance against corrosion, electrolysis, and prolonging the life of your cooling system components, mostly your radiator. I had a lot of people come up and say, gee, I just had to replace my radiator because of electrolysis and the metals were pitted, but this coolant, this is a little expensive. I said, you know, had you had this coolant to begin with, you might not have had to have bought that radiator.
And that brings up a good point that this is actually reusable.
It is reusable, so if you have to do any kind of repairs or maintenance and you have to drain your coolant out, you can reuse it. You want to filter it just to make sure that it's clean, but I would definitely save it and reuse it.
So, Mike, talking about racing, this stuff is NHRA certified.
It is. In fact, Evans is an NHRA contingency sponsor. This July will be 2 years, and since then we've signed up hundreds of racers that are using Evans on the track. In fact, Steve Williams won the national championship using Evans coolant last year.
Well, the purpose of coolant is to get radiant heat out of the engine. So tell me about how Evans works better than a water-based coolant.
Okay, you know, that brings up a real interesting point. Water loses 96% of its ability to transfer heat when it turns to vapor. That's bad. So with Evans, it remains a liquid at the higher temperatures, so you always have liquid to metal contact. Metal temperatures are under control. Even if the liquid coolant, Evans, is getting warmer because it acts like a sponge pulling the heat away, the metal temperatures are under control and you avoid those hot spots and those metal temperature spikes.
Well, Mike, I want to thank you for coming by and explaining more about Evans coolant to us, and hope to see you at the track.
Yeah, it's good to be here again. Thanks for having me.
Up next.
I don't believe what I just saw. With the engine on our Superfloat docking cart, we can bolt up a set of our dyno headers. These are Hooker Super Comps with a 1 3/4 inch primary size. The thick mounting flange resists warpage and creates a great sealing surface. The collector is 3 inches in diameter, and we are running EVACs that attach to the valve covers.
Hot Shot's secret adrenaline racing oil is exactly that. Intended for excellent protection for nitrous and supercharged engines, where high output is combined with abuse of high RPMs. This makes it a great choice for naturally aspirated racing engines as well. It provides an excellent bearing oil film thickness for larger bearing clearance engines. It's compatible with all types of racing fuels as well.
It's infused with FR3 nanotechnology. It reduces friction, improves horsepower, and has improved aeration control. It's intended for off-road use only, so it cannot be used with EGR systems, catalytic converters, or DPF systems. We are just going to go for it and make some pulls from 4,500 to 6,800 at 32 degrees of timing, so let her rip there. Did it break 500?
I think so.
It broke 500? Woo, look at that.
First yank, we got 531 on power, 470 on torque. Everything else looks good. Fuel, let's cool it back down a little bit. We got a little heat in the oil now.
Yep.
And make another rip the same RPM.
Yep, same RPM.
All right. I think I saw a decent number out
That
of
was
that
decent.
one.
Again, rings breaking in, all kinds of crazy stuff. Whoa, look at that!
61.
61.
491 pound-feet.
Okay, all right. Now
Man.
again, when your engine's at operating temperature and the oil is thinner, that actually it takes more. It's called pumping loss, right? So the easier it is to pump, the less parasitic loss it has, the more power it makes. That is unbelievable for a budget rebuild. I mean,
Yeah.
we did put a set of heads on it, right?
Yeah.
All right. So
Nitrous.
now, nitrous.
The nitrous system we're using is a sniper kit from NOS. Now this kit is a wet system that introduces fuel and nitrous into the spray bar that's mounted under the carburetor. Both of the solenoids are triggered by a micro switch that's mounted on the passenger side of the carburetor. Now this kit is adjustable from 100 to 150 horsepower in 25 horsepower increments. The kit comes with everything you need to bolt it onto your car and go out to the track and have some fun. The bottle does not come filled with any nitrous, so you'll have to take that to a local speed shop or air gas company and get it filled.
All right, the oil is heated back up. The only change we have made is we have added a plate kit that has 100 horse of nitrous. Now, we're not doing anything to the carburetor. If the carburetor is right, we are introducing fuel and nitrous, so I think it'll be okay. I'm arming it. Are you ready?
All right, here we go.
Let her rip. Oh my God.
Saw some good numbers down there on the gauges.
Nitrous kills me.
672, 669.
This thing will handle more nitrous than we can put to it. The limitation we really have is the block.
Well, I know how you are. Sometimes you like to just go all in, and sometimes you like to be a little conservative. So were you going to jump to the 125 or the 150?
150. Why even mess around?
I love it.
Why even mess around? 672.
Increasing the horsepower is as easy as changing the jets. Just make sure to follow the chart on the nitrous instructions.
I don't believe I just saw. 720 and 704 pound-feet of torque. You know, I bag on nitrous a lot, but there's no denying what it will do when it's used correctly. What people do is they abuse this. It's like anything else. They'll abuse it and put it on stuff that won't take the power. This actually will take the power. So
Now this kit's under $500.
yes, it's incredible. We have a very, very economically friendly 720 horse engine.
Yeah.
What do you think?
I love it. I think it's a good one. Another one bites the dust, right?
Woo! For more information on any of the crazy stuff that you've seen on today's show, visit PowerNationTV.com.
Designing a fuel system for an aftermarket vehicle has become somewhat of a science. Aftermarket pumps require return-style regulators, pre- and aft filters, and the size of the line that's used in the system is also critical. Some pumps are pulse-width modulated and some require a relay so the vehicle's electrical system can handle the extra amperage. Something else that's very important is how the system is routed. If your components are too close to heat sources or moving parts, you could put your system at risk.
Automotive-based fuel systems also have other applications, and that's what we're going to talk about today. Our dyno cell received a new fuel system to supply the engines that we test. And when we were designing this, we wanted to lay it out so it would test either carbureted or fuel injection systems without having to be swapped over or unhooked. The fuel pump we run on all of our engines is this 1.5 horsepower, 230 volt Weldon. It's the only thing being reused in the entire fuel system. It's controlled by a speed controller, which allows us to increase or decrease the volume of fuel through the regulators. For the rest of the system, we called upon longtime PowerNation partner and a leader in the automotive aftermarket, Holley Performance Products. Now, we used a mix of Holley and Earl's Plumbing to get the job done because we knew that quality cannot be sacrificed in a dyno cell like this.
After the pump is a Holley 460 gallon per hour VR Series billet fuel filter. It's designed for hot street and race applications. It is a post filter, so it has a 10 micron element. The inlet and outlet use -12 O-ring fittings and the filter is black anodized. From there, the feed line goes through the wall of the dyno cell. Sealing it is an Earl Seals It firewall grommet. The other line we will get to in just a few minutes. When that line enters the dyno room, it comes up to this Y block. From there, it splits to 2 Earl's ball valves, and that's what feeds both of our regulators. The top regulator is for fuel injection, the bottom is for carburation. Now this line that joins the two actually sends the signal to our pressure sensor to tell us what kind of fuel pressure we have out at the console. Now both regulators have a return line. The return lines go down the wall to another Y block and feed back out to the fuel cell. From the regulators, we go to another Y block. That one's set up with dry brake connections. A single line then comes up to our fuel flow meter. This is what tells us how much fuel the engine is actually consuming when it's running. Finally, another Y block, and those two lines feed the carburetor or the fuel injection.
We'd like to thank Holley Performance Products for getting us up and running. Now, if you have an application for a fuel system, whether it be for your hot rod, a test stand, or even your own dyno room, give them a call and they'll get you fixed up.